Okay, for this problem, we're gonna be expanding the logarithm. So expanding, I think of we're turning this single logarithm into multiple logarithms, like we did when we were just condensing the logarithm into a single logarithm. So for this, let's distribute this third power into whatever's inside this parentheses. Okay, so this is going to be natural log time of 6 to the 12th power. Okay, exponent rule to the 7 to the third. Okay, this is the one right here. Okay, now we can use logarithmic properties. For this, we have the quotient rule. Okay, because when you look at this quotient right here, it could be it's a thing of subtracting. So we're gonna do natural log of 6 to the 12th power minus. Let me erase this. Sorry. Natural log of 6 to the 12th power minus natural log of 7 to the third power. Okay, two natural logs. Now we're gonna be using the power to bring this 12 to the front of the natural log, including this 3 in front of the natural log too. So 12 times natural log of 6 minus 7 times natural log of, oh sorry, my bad, 3 times natural log of 7. Okay, I sometimes make mistake, but I identified quickly, so sorry for that. Okay, that was just the quotient rule. Our answer is just basically this, because we expanded it, the logarithm. We expand this single logarithm into two logarithms. And then if we were to condense this, we have to go backwards using the quotient rule, product rule. For question 7, we have log base 7 of x to the third over y and to the fourth power. So this is basically the same as the last question. Let's distribute this 4 into all of these inside this parenthesis. We get log base 7 of x to the 12 over y to the fourth power. Now we're going to be using the quotient rule and make these subtract each other with two different logs. So we have log base 7 of x to the 12th power minus log base 7 of y to the fourth power. And then we're going to be using the product rule by bringing these exponent to the front of this log. So there's going to be 12 times log base 7 of x minus 4 times log base 7 of y. And this is our expanded form for this question. For question 8, we have log base 2 of u to the 6th power times b squared. Okay, so for this, we're going to be using the product rule, okay? By making u to the 6th power plus v squared, okay? So we have log base 2 of u to the 6 plus log base 2 of v squared. And we're going to be using the power rule by bringing this exponent to the front of this log. So we have 6 times log base 2 of u plus 2 times log base 2 of v. This is our completed expanded form of this logarithm. For question 9, we have natural log of x to the third over y to the fourth. Okay, so for this, we're going to be using the quotient rule again. So it's going to be natural log of x to the third minus natural log of y to the fourth, and then use the product rule. 3 times natural log of x minus 4 times natural log of y. And this is our completed expanded form of this logarithm. For this final question, we have log base 5 of the square root of u times v times w. Okay. So when I first learned this, I saw this problem my teacher gave me. I was a little bit confused because back in algebra 2, I didn't do any expanding or condensing logarithm that has square roots in them or a fraction. But for pre-calculus this year, I just learned how to deal with this type of problem. Okay, so let's look at this. Let's turn this square root to 1/2. Okay, so log base 5 of u v w to the 1/2. Okay, because 1/2 is just basically the square root. Okay, and Let's bring this exponent to the front of this log. So yeah, using the product power rule. Sorry. So 1/2 times log base 5 of UEW. Now we have this. Basically in here is just basically the product rule because they're all being multiplied. So let's write this as 1/2 times log base 5 of U plus log base 5 of B plus log base 5 of W. Okay, and this is technically going to be our final answer for this problem.